here we go. Here's the first full section worth of proofs for you. And hopefully this will make a lot more sense today than it did on the example I did the other day. So algebraic proofs are probably the easiest proofs to understand, and that's why we start with them before we get into our geometric proofs. And we got all these properties of real numbers that we're going to use for our algebraic proofs. And they're pretty straightforward. All these addition, subtraction, multiplication, basically they're just whatever you do to one side, you have to do it to the other. So if I add a number to one side, you got to do it to the other. And I'll show you where these properties come into play. Hopefully we all remember our distributive property, which I'm sure we do. Or if I have something like that, I just got to take the term on the outside of the parentheses and distribute to each of the terms on the inside. So A times B and A times C. So that would be our distributive property. Our reflexive property, that's just saying something is equal to itself. And we're going to use that sometimes. So I could say a number is equal to itself. Or a lot of times we'll say a segment is equal to itself. Or possibly a segment is congruent to itself. Okay, those all deal with the reflexive. Symmetric means they're good on both sides, so I can flip them around. So basically, if A equals B, I can flip it around and say that B equals A. And we'll use that sometimes because we got to be very specific in our proofs. The transitive property, that was like our law syllogism from the other day. Basically, if A equals B and B equals C, then A has to equal C. So if A equals B and B equals C, then A equals C. And it could be for congruence, it could be a lot of different things. And substitution, anytime we just replace something, so for example, if I replace 4 minus 3 with 1, that's substitution. I'm just replacing 4 minus 3, I'm substituting in 1. Yeah, and we'll do all these and you'll see them here. We're also going to do algebraic proofs. That's what our section's called. So all it is the proof using algebra, basically solving for a variable. And a two-column proof, we introduced that the other day, right? Because we don't want to worry about paragraph proofs. We use two-column proofs way more often because they're more formal. They're easier to see. You can tell which reason goes with which statement, all those things. And so we talked about this yesterday, having two columns, a column of statements and a column of reasons. And you put a number there so you can know which statement goes with which reason. So the first part of your assignment, you're just going to get used to using your properties. So all it does is state the property that justifies each statement. So if 2x plus 5 equals 11, then 2x equals 6. So all I'm saying is what happened when I went from this to that? Well, it looks like we subtracted 5 from both sides. So all I'm going to say is I use the subtraction property. So it's subtraction, it's just whatever you're doing, whatever property you're actually using to get from one part to the other. Same thing with here, it says if measure 1 equals the measure of angle 2, and measure of angle 2 equals the measure of angle 3, then 1 would equal 3. So basically, measure 2 is equal to two different things, 1 and 3, which means 1 has to be equal to 3, which is our transitive property. Transitive. So all we're doing is just stating which property are they using there. Okay, let's actually do a proof here. If the distance d of an object travels is given by this equation, d equals 20t plus 5, the time t that the object travels is given by t equals d minus 5 over 20. Write a two-column proof to verify this conjecture. Well, two-column proof. So I'm going to have statements on the left and reasons on the right. And I always start with the given. So the given was d equals 20t plus 5. And it gave it to us, so we call it the given. Always start with the given. Well, for 2, you got to think about, what am I trying to go to? I'm trying to go to this. Trying to go to that. I'm trying to solve for t here. So basically, I want to solve for t. So let's take it step by step. So my first step is I'm doing what? I'm looking at my algebra here. What do I want to do this to get t by itself? Well, you got to think back. You always do the inverse of what's being done. Can't touch the 20 that's connected to the t, so I got to get the plus 5 out of there first. So we're going to subtract 5 from both sides. So I'm going to put minus 5. And what property is that? Well, the subtraction property. And if you want to simplify it, say like SUBT for subtraction, that's fine. Subtraction property. And now let's go ahead and subtract. So for 3, well, I can't combine those, so I just write d minus 5 equals 20t. Well, when I replace what I just did, we just call that substitution. We just put it in. So substitution. Well, now take a look at my next step. I want to get t by itself. So what do I have to do to the right side to get t by itself? Well, we're multiplying by 20, so the inverse is divide by 20. So I'm dividing by 20. Or I could write the division symbol, whatever you want. And what are we doing to both sides? The division property. I could put div prop, that's fine. So now for step 5, I have d minus 5 over 20. Can't do anything with that, so I'll just leave it, equals t, right, because the 20's cancel. And we just substitute it again. So it looks like I'm done, right? It looks like I have my t equal to that. Well, if you notice, the t is on the left side of the equal sign. So I got to get the t on the left side of the equal sign here. So I'm going to rewrite this for my 6th step and say t equals d minus 5 over 20. Because we got to be very specific what we're trying to prove. And if you remember, when I just flip it on each side of the equal sign, it's just called our symmetric property. Symmetry property, whatever you want to say. Symmetry, symmetric, something like that. So I know that you're talking about the symmetric property. Okay? So just writing out each step and justifying it, giving it a reason on why I was able to do that. Because I know it seems like a lot of extra work writing out these reasons, but that's why we have proofs. Because you actually have to prove why something works. We actually have properties on why that algebra works when you actually solve it. So that's why we're doing that right now. So let's try one more 2-column proof here. So if CD is congruent to EF, then Y equals 8. So if I look, if, that would be my given, and the other part is what I'm trying to prove. So that's going to be my very last statement. So let's start off with statements and reasons here. And we always start off with our given. So one is CD is congruent to EF, and that's given. Okay, well, I have one step in here before we can do anything else, before I take a look at my picture and what's going on here. Oh, my picture is screwed up. This should be CD and this should be EF. Okay, before I look at my picture, I have one thing. Right now, I have congruence, and I want to get to equality. That's important. Anytime that's the case, I'm going to have to switch from congruence to equality. So I'm going to do that right away. So I'm going to say CD. Notice how I do not put the bar over top because I'm just saying the measure, how much the distance is from C to D. So CD equals EF. Well, going from congruence to equality or equality to congruence, that's just the definition of congruence. So I'm going to say definition of congruence. It's really definition of congruent segments, but definition of congruence. I'll just do that every single time I go from equals to congruent or congruent to equals. All right, well, for 3, somehow I got to bring this variable y into play, right? Because I'm trying to prove this y equals 8 at the end. I'm trying to prove this y equals 8. Well, let's use our picture over here. So CD is equal to EF. Well, can I set these two equal? 3y minus 9 and 15. So that's what I'm going to do. I'm going to say 3y minus 9 equals to 15. And I can do that because I've already stated that CD is equal to EF. So basically, I'm just plugging in 3y minus 9 for CD, and I'm plugging in 15 for EF. So if I plugged them in, I really substituted them then in. Substitution. You just put something in for something, you're substituting. So I put in the 3y minus 9 for CD, because that's the length of CD, and I put in 15 for EF. So step 4, now it's my algebra. So I got to add 9 to both sides. That's my addition property. And then we got to substitute in, see what it looks like. So 3y equals 24 now. And we said that's substitution property. And then we got to divide by 3. So for my sixth step, we're dividing by 3. And that's our division property. And it should be good to go at the end. So seventh step, I'm left with y equals 8, which we were trying to prove. And I just substituted at the end there. Substitution. So there we go. So we just got to go through and we got to have a reason for every single step. Okay, and the more we do these, the more you're going to get used to it. And I know it's a lot to write, but that's just a part of proving something. You got to have a reason behind everything. So just a few problems, just stating the property that you're using, and then you got a couple proofs at the end there.